Good morning, myself V. Pavan Kumar, working as an assistant professor of CSE AIML department in MLR Institute of Technology. In this class, I am going to discuss about elementary data link layer protocols. So, before going to the discussion regarding this particular elementary data link layer protocols, you should have a clear idea about the data link layer. So, in data link layer, usually the data will be transmitted in the form of frames. So, the data will be coming from the higher layers, that is the layer above the data link layer is network layer. In the network layer, the data will be in the form of packets, and from then the packets will be converted into frames in the data link layer. So, coming to the discussion regarding this particular elementary data link layer protocols, we have three elementary data link layer protocols. They are unrestricted simplex protocol, or you can also call it as a utopian protocol. And the second protocol, we call it as a simplex stop and wait protocol for noisy channel. And the third elementary data link layer protocol is simplex stop and wait protocol for noiseless channel. So, these three comes under elementary data link layer protocols. So, we will have a clear discussion about each and every protocol now. So, unrestricted simplex protocol, or it is also known as utopian protocol. So, what is this particular unrestricted? So, we have a clear discussion about each and every term included in that particular elementary data link layer. One is unrestricted, or it is also called as unrealistic. So, unrealistic in the sense practically it is impossible to implement. So, you cannot implement practically, it is not at all possible to implement this particular protocol practically. So, unrestricted means there is no restriction at sender side and at the receiver side. So, no restriction in the sense, say for example, this is the sender and this is the receiver. Sender can send infinite amount of data to the receiver, and receiver can receive infinite amount of data from the sender. That is, we call it as an unrestricted. There is no restriction for the flow of data. So, restriction in the sense, no restriction for the flow of data. That we call it as an unrestriction. And unrestricted. Coming to this particular simplex. So, this is one way of communication, one mode of communication usually called it as. So, how many types of communications are there? Usually, we have three types of communications. One is simplex, half duplex, and the third one is full duplex. So, we are already had a discussion about all these particular topics. So, simplex in the sense the data will be transmitted only in one direction. That means the data can be flowed only from sender to receiver. This is what the simplest way of communication. The data cannot be transmitted from receiver to sender. This is not possible in this particular case. That we call it as a simplex. So, whereas half duplex means the data will be transmitted in both the directions but not at the same time. So, the best example for this particular half duplex is walkie-talkie. And full duplex in the sense the data will be transmitted in both the directions and at the same time. So, the best example for full duplex is telephonic conversation. So, these are all the different modes of communications where we call it as. So, here the name itself indicates simplex. So, simplex in the sense the data will be transmitted in only in one direction. Next, assumptions to implement these protocols. So, we have some assumptions. This means ideal, realistic protocol. That means there is no chance for error free. So, it is completely error free transmission. So, we have some assumptions to implement, but which is not practically possible to implement these particular assumptions. First is that unrealistic means impossible to implement. This we already discussed. So, it is not at all possible to practically implement this particular protocol. The reason is that, so there is no chance that the data will flow free from errors, and the data, there will be no possibility of flow control, error control. This will never possible in a realistic mechanism because of some network issues, by network delays, anything might be happen in this particular case. So unrealistic means impossible to implement. This is not at all possible. So that means this is 100% perfect. This is just like a Mr. Perfect. It is 100% perfect in the sense no chance of loss of data. Next, what is the second assumption? Transmitter and receiver is always ready. So for example, transmitter in the sense sender. So he is a sender, he is a receiver. Transmitter and receiver is always ready. Sender, transmitter is nothing but sender. Sender will continuously send the data, and receiver should have the capability to completely receive the data all the times. So is it possible to implement practically? Sender will send the data only when the sender is having the data to be transmitted, and the receiver will receive the data only whenever the sender sends the data. But in practical, what here the assumption is that sender should continuously send the data, and as well as receiver should continuously receive the data. This is not at all practically possible to implement in the real world scenario. This is the second assumption. And the third one is sender has infinite amount of data. So which is not at all possible to implement this particular scenario. Infinite amount of the data. So the data must be continuously available at the sender side, infinite amount. So there is no countable amount of the data, which is not at all possible to implement practically. And the receiver has infinite buffer space. So receiver has limited buffer space, it will not have infinite buffer space. So this is not at all possible to practically implement, and there is no errors. So already I told you, no errors in the sense, communication channel is free from errors. Communication channel is free from errors. And no flow control mechanism is required. No flow control mechanism in the sense there will be no loss of data. So whenever the data is being transmitting by the sender, that particular data will 100% received by the receiver. There is no chance that data might be lost, or data might be corrupted, or data might be hacked. So it is continuously the data is being receiving by the receiver. So the no flow control mechanism is being required. Processing time is neglected. So what is this particular processing time? Processing time is neglected in the sense whenever sender sends some amount of the data, after receiving the data, receiver will wait some time to process that particular received data. So whatever the time that is being waiting by that particular receiver, it is neglected. Even though if it is large amount of time that the receiver is waiting to process that data, that particular receiver, the time which is being waiting by the receiver is neglected. That this processing time is neglected. And the next assumption is machines always work properly. So which is not at all practically possible in this particular scenario. So there might be a chance of network issues, there might be a chance of network delays. So it is not at all, there might be a chance of hardware requirement problems. There might be a problem, there might be a chance of problem with respect to software. So in all the cases, so machines will not work 100%. So that is, this is ideal. That means the assumptions, with respect to these assumptions, we come to a conclusion that this is a Mr. Perfect protocol, but it is not at all possible to practically implement this particular protocol. This is unrestricted simplex protocol, or you can call it as an utopian protocol. And coming to the discussion regarding the second protocol, simplex stop and wait protocol for noiseless channel. So already we had a discussion regarding the simplex. So I'll just clearly clarify each and every term about the title. Simplex in the sense the data will be transmitted only in one direction. So that is the best example for this particular simplex is keyboards and monitor. Keyboard, you are going to give input from the keyboard, and monitor you are going to get output from the monitor. Simplex means data will be transmitted only in one direction, that is sender, receiver. Sender, receiver. This is the data will be transmitted only in one direction. Stop and wait protocol. So what is this particular stop and wait protocol? Though it is a simplex protocol, here we have a relaxation of getting the acknowledgement from the receiver. We also get the acknowledgement from the receiver. So what is this particular stop and wait protocol? So for example, here is the sender, here is the receiver. Sender sends one frame of data, say this is a frame, and sender will wait for certain amount of time, and after that he will receive an acknowledgement. That means here acknowledgement will be received by the sender. That means the data will be transmitted in both the directions. So this is one kind of relaxation in this particular simplex stop and wait. Stop and wait in the sense, so sender will send a data in the form of frames and wait for certain time of period, and again after receiving the acknowledgement, again sender will send one more frame. For noiseless channel, what is this particular noiseless channel? Noiseless channel in the sense the communication channel is free from errors. So noiseless channel means communication channel. So here we are transmitting the data in communication channel which is free from errors. So that is what I have discussed here. Stop and wait means sender sends a frames and wait for an acknowledgements. Even though it is simplex, the receiver can send acknowledgements. This is what we had a discussion. Noiseless channel means error free, that is communication channel is error free. Here the problem is flow control. So what is this particular flow control and how you are going to solve this particular problem with respect to noiseless channel? Flow control in the sense, so here the receiver is having the finite buffer space or the processing speed of the receiver is finite. So for example, sender sends 100 frames of the data at a time, but whereas the receiver can receive only 50 frames of the data at a time. Rest of all the 50 frames of the data will be lost. So as it is having the finite buffer space, that means the buffer space is limited. It has been restricted to only accommodate 50 frames of the data. And the processing speed in the sense, for example, sender sends the data and the receiver receives that particular data. After receiving that, the receiver must process that particular data. Even the processing speed is finite, whereas in this unrealistic protocol or utopian protocol, it is infinite in the sense, so you will have infinite processing speed. So the processing speed is also neglected in that particular case, but whereas here the processing speed is being counted. So that is what is the main problem with respect to flow control in the sense, fast sender. So for example, sender, receiver. Sender continuously sends the frame, but the receiver can receive only some frames of the data at a time. What will happen? The rest of the frames will be lost, or it is not in a position to receive that particular frame. So what is the case here? That particular problem we call it as a flooding. So fast sender, slow receiver. So sender, receiver is not in a position to receive that many number of frames that is being transmitted by the sender. So that problem we call it as a flooding problem. So to overcome this particular problem, we have introduced the concepts of acknowledgements. So acknowledgements in the sense, so what is this particular acknowledgements? How this particular acknowledgement concepts have been introduced? Because of a problem to, what is the problem that is to overcome? What is the problem? Flooding problem. What is an acknowledgement? Say for example, here we have a sender and here we have a receiver. Sender sends one frame of the data, say for example frame 0, and after some time, so every frame will have a timer. So for example, the time period is 30 milliseconds. So once this particular frame is being transmitted by the sender to the receiver, it waits for an acknowledgement up to 30 milliseconds. So for example, within the 30 milliseconds of time, the acknowledgement for the frame 0. So for example, we call it as an acknowledgement 0. So the time period is 30 milliseconds. It has been received. So there is no chance of overflowing of the data, because if the sender wants to transmit the next frame of the data, he has to wait until the acknowledgement is received for the previous frame. So you are going to overcome the problem of flooding with this particular kind of a concept called acknowledgement. So what is the next scenario? In the next time, after 30 milliseconds of time, whenever the receiver sends acknowledgement and whenever the sender receives that particular acknowledgement, sender will send one more frame, that is frame 1. In such a way, the process will continue. So there is no chance of flooding of the data. So until and unless the receiver sends an acknowledgement, sender cannot send one more frame. So the problem that is being in this particular case is flooding, which is being overcome with a concept called acknowledgements. So that is what the second elementary data link layer protocol, that we call it as a simplex stop and wait protocol for noiseless channel. So noiseless channel in the sense communication free channel. And coming to the third elementary data link layer protocol is simplex stop and wait protocol for noisy channel. So already we had a discussion regarding what is simplex, what is stop and wait, and what is noisy channel. Noisy channel in the sense the channel is, communication channel is full of errors. Communication channel is not error free. We can also call it as not error free. So not error free in the sense there might be a chance that the errors might be happen whenever the data is being transmitted by the sender to the receiver. The data might be corrupted, or data might be lost, or data might be damaged. So in this particular scenario, say for example, so he is a sender and he is a receiver. Sender, receiver. Sender have transmitted one frame of data. So the data will be transmitted in the form of frames. So sender is transmitting one frame of the data. So how this particular scenario takes place is that, say for example, whatever the frame that is being transmitted by the sender to the receiver, it is error free. There is no error with respect to that particular frame. So for that he sends an acknowledgement. Here also we will have the timer. Each and every frame will have a timer. Timer will be maintained by the frame. So for example, it is 20 milliseconds. In the last scenario we have taken 30 milliseconds. Now we are taking 20 milliseconds. So the frame which has been transmitted by the sender is error free. So no problem with that. The receiver have sent an acknowledgement for the transmitted frame. So no issue with this particular scenario. And coming to the second scenario. So for example, after some time, after receiving the acknowledgement for the frame 0, so for example, so no, we have not introduced any kind of sequence number, leave it. So this is a frame, and after that sender sends one more frame. For example, this particular frame is being corrupted. So how the receiver will come to a conclusion, this particular frame have been corrupted. So in order to identify or detect the errors, the receiver will calculate whether the frame is free from error or not with the help of a concept called checksum. So he will calculate the checksum at the receiver side. Receiver will calculate the checksum, and with the help of that particular result, receiver will come to a conclusion whether that particular frame is being corrupted or not corrupted. So for example, if the particular frame is corrupted, what will happen? So for example, this frame is corrupted. Simply you will discard this particular frame. The receiver will discard this particular frame. After again 20 milliseconds of time, again the sender will send the same frame again. Now he will send an acknowledgement. He will send an acknowledgement for this particular frame. After some period of time, after receiving the acknowledgement, again the sender have transmitted one more frame. Now what happens in this particular scenario? Acknowledgement is being transmitted by the receiver, but this particular acknowledgement is being lost. So what happens whenever the acknowledgement is being lost? So after 20 milliseconds of time, what the sender will do? Again he will retransmit the frame. Again he will retransmit the same frame again. So how the receiver will be able to identify whether as it is an original frame or a duplicate frame? This is a duplicate frame. This is a duplicate frame because the content of this particular frame is already been included in this particular frame. So this is a duplicate frame. So how the receiver will be able to identify that whether it is an original frame or a duplicate frame? So this particular duplicate frame concept will be overcome, this problem will be overcome with a concept called sequence numbers. it will be overcome with a problem with a concept called sequence numbers. What is this particular sequence numbers? So for example, we have mentioned some sequence numbers for the frame which is being transmitting after the frame name. So for example, this is frame 2. Again, as acknowledgement is being lost for this particular frame 2, that is ACK2. So for example, for frame 2 you will be getting ACK2, for frame 1 you will be getting ACK1, and so on. So for frame 2, we have the receiver have transmitted an acknowledgement, but the acknowledgement is being lost because of network delays or some network issues. After waiting a certain period of time, as the timer is being on at the sender side, so after 20 milliseconds of time, again the sender will retransmit that particular frame to again. Now with the help of this particular sequence number, the receiver will be able to identify that this is a duplicated frame because already frame 2 is being already received by me. So what it do is that in perception, the receiver will think that whatever the acknowledgement that have been transmitted, it might be lost in the due to corruption or some network delays. So simply it will transmit the ACK2 again. This is the scenario that is been happening in the simplex stop and wait protocol for noisy channels. Now actually how data will takes place, how data transmission takes place from sender to receiver. So I'll have a clear idea about this. I'll clearly tell you how this particular data will happen. So for example, here we have a sender and here we have a receiver, and the sender side we are having, say for example, 3 layers. So here there is a network layer, data link layer and the physical layer, and even at the receiver side also we are having 3 layers: network layer, data link layer and the physical layer. So that to this particular network layer, the data will be coming from the higher layers. So what is the higher layer to this particular network layer? Transport layer. From the transport layer, the data will be coming to this particular network layer. So in this particular network layer, the data will be converted in the form of packets. Whenever it reaches to this particular data, the data here, the frames will be framed. Here we are going to construct a frame out of this particular packet, and we are going to transmit this particular frame to this particular physical layer. And in the data link layer, whenever the frame reaches, the network layer is going to extract the packet from this particular frame, and it is going to transmit the data acknowledgement. So this is the data transmission and this is the acknowledgement transmission. So so that is how the data will be transmitted from sender to receiver and as well as receiver to sender. So in OSI model, we have already seen that the data will be flowing from higher layers to lower layers. That is the network layer. The layer above the network layer is, for example, transport layer. In the transport layer, the data will be in the form of segments. So whenever that particular data is being reached to the network layer, it is going to convert it into the packets, and from the packets in the data link layer, it is going to convert in the form of frames, and in the frames, the data will be transmitted to physical layer, and in physical layer, the data will be transmitted in the form of bits. So this is what this process happens in all the 3 protocols. So that is simplex protocol for noiseless channel, and unrestricted simplex protocol or utopian protocol. In all the 3 elementary data link layer protocols, the same transmission of data takes place. So this is what about the elementary data link layer protocols. Thank you for giving me this opportunity. Thank you very much.